Oh, yeah. So I'm going to be speaking in English because I cannot put 2 words in technical Russian anymore since I moved to US. So yeah, I will be talking about CSP. What is CSP? CSP stands for Canadian Staging Professionals. And like if you want to make some money and stop pushing buttons, you can, well, anyway, whatever, it's a joke. It's just, the thing is that if you search for CSP in Google and switch to images, first thing you see is this logo on about Canadian Staging Professionals, and this is some kind of shady profession where where they teach you how to stage a house when you sell it, so you attract more buyers. So yeah, we are not going to talk about that CSP. We are going to talk about content security policy. I work at a company called Shape Security, and we work on a network appliance which modifies modifies HTTP responses that are going to the browsers from a web server. So since we modify content, we need to take care of CSP if a web server is using CSP. But before going there, I'll explain what CSP is. CSP is a very cool new technology that mainly fights cross-site scripting and helps with fighting cross-site scripting, UI redressing attacks. It helps to avoid mixed content vulnerabilities. And so main problem exploited by cross-site scripting is that browsers cannot distinguish between scripts that intended to be part of your web application and scripts that being maliciously injected by third party. So what CSP is doing, CSP is actually allowing to disable certain features in the browsers. For example, by default, when your web page says loads a script from, say, jQuery.com, like you don't have control over it, right? You just have a HTML which says script source equals HTTP whatever jQuery.com. So you cannot. That capability of loading the third-party script is there, and there is no way to disable it. So CSP provides a mechanism to disable certain features. Just really like brief history. So it was first introduced in 2009, and so it's 6 years, but it's not really popular, and like you'll see on next slides why it's not popular. But yeah, it was introduced in 2009. CSP level 1 spec was out in 2012. Now CSP 2 level 2 is current standard, and there's active work being done on CSP level 3. Most modern browsers, this is for CSP level 1. So basically every browser supports CSP level 1 except Opera Mini. And CSP level 2 is supported by Chrome and Firefox only for now, but other browsers are catching up. And adoption among websites. So we scanned Alexa top 100,000 websites, landing pages only, and only 0.2% are using CSP, which is kind of strange. And many of these policies, many of content security policies are nonsensical or even broken. And basically, we decided to understand like why adoption is so slow, and like what can we do to make it faster, and like how can we help people. Okay, now the actual explanation of what CSP is. So it is a string that can be delivered either through HTTP header or as a meta tag on your page, and basically it's this content security policy header, and it consists of directives and source lists with directive. So for example, to limit where your web page can load scripts, you just say script source, and you can have one or more expressions that can be like scheme source, host source, or like keyword source. And basically, for example, this page says that this policy says that I want to load scripts only from HTTPS schemes, and or only from example.com, or only from myself. what happens if you have multiple expressions? So basically, spec is saying that you have to match at least one source expression to match script that you want to load. And like, for example, if you have a policy that's served from site.com and your web page has a script that's being loaded from site.com, it will load because it exactly matches self. So the source of the script that we're testing, it's exactly the same as the origin from where the policy is delivered, which is site.com, so this script will load. API.site.com wouldn't load because it doesn't match anything. It doesn't match self, it doesn't match HTTPS, and it doesn't match star.example.com. Or HTTPS Google.com will load because it matches the scheme. It matches one of the conditions, like HTTPS is okay. HTTP example.com also wouldn't work because policy actually says that domain name should end with .example.com, and we don't have that condition. The condition is not satisfied. And like API example.com would work because even if it's over an insecure scheme HTTP, but API.example.com matches star.example.com. And like this one will also work. Now matching. So if you have a policy that says script HTTPS, what would happen with these three scripts? So obviously, like, first two would work because they match HTTPS scheme, and like WebSocket, for example, wouldn't work. It's just like I'm trying to explain like basics of matching, of source expression matching. Say script source says I only allow scripts from a.com, from domain that matches a.com. So what would happen here? I'm sorry, first one is actually incorrect. It should work. Sorry. Yeah, a.com port 8080 wouldn't work because if scheme is not specified, I have a slide about it, but basically if the second directive assumes that port is default port for either HTTP or HTTPS. So it will match only port 80 and 443 with corresponding schemes. This one is important. So if you have a path part in your source expression and it doesn't end with /, that means there has to be exact match. So it literally means that there must be exact match. So basically a.com/b would work and anything else wouldn't work because there is no exact match. And if your path ends with /, that means anything that contains that path and domain name would work. So basically, yeah, a.com.b wouldn't work because there is no exact match, but anything that contains a.com/b/ would match. And basically, yeah, that's the rules. And it's not really clear from the spec. Types of resources that you can restrict with content security policy. It's like script, style, images, fonts. Form action is where your form submission can go. And like child sources is for like all the childs, like basically it's frames. Frame source is obsolete directive, and it's going to go. It's going to disappear in CSP level 3, and it's replaced by child. Actually, object is for objects. Connect is where your XML HTTP request or like WebSockets can connect to, and media and base and sort of self-explanatory. These are directives that are accepting source lists as like arguments. And there are three other types of directives. That the frame ancestors is basically replacement for X-frame options. Media type is you can list what plugin, what MIME types your web application can contain. And report URIs, we'll come back to report URIs. Basically where your CSP violation reports are going to be sent. There are 4 keywords in CSP. We saw self, which is basically self is the alias for the origin from where your content security policy is coming. There's keyword none, there's keyword unsafe inline, and unsafe eval. And last two are pretty dangerous and should be used with great caution. And here's some example. For example, if you have script source none and style source none, it basically means that you do not allow any scripts to be, any third party, any external scripts or styles to be loaded by your web page. So basically, none of these HTML elements would work, would be evaluated by the browser. Basically, it will not load any script from third party. It wouldn't let any inline scripts as event handlers, and it also doesn't let any string to JavaScript interpretations. Basically, evaluation is not allowed. So it's kind of safe thing to do. Non-keyword is safe to use if that's what you want. Unsafe inline, basically, it whitelists. It makes an exception and it allows an inline script to appear in your web page. And basically, that means that if you have script source star unsafe inline, it means that you let scripts to be loaded from anywhere, and you also allow unsafe inline, which is basically how cross-site scripting appear on your web page. Cross-site scripting payloads appear on your web page, and basically that means that it still loads scripts from any third party. It allows inline scripts as event handlers, but it doesn't allow eval. And to allow eval, you need to actually use unsafe eval. Well, I'll go faster over this. Basically, try to avoid using these keywords, unsafe inline and unsafe eval, which means you don't. It's better not to have any inline scripts on your web page to allow in the first hand. If you still have to have a script on your web page, inline script or inline style on your web page, you can granularly whitelist them, either through specifying a hash of the content that you want to appear on your web page. For example, if you have to have an on-click handler, for example, you can calculate the digest, SHA-256, for example, digest, and you put that value that you calculated in your actual content security policy. And only inline script whose digest matches whatever you declared in your HTTP header in content security policy would be evaluated. Anything else will be just blocked. And it's useful when you don't have dynamic content. But if for example, if your web page is serving different scripts per user agent or per platform, you cannot even you still can have multiple hashes declared in your content security policy, but it's not a good idea. And there's another mechanism, a nonce-based mechanism. Nonce is number used once. So you generate a random number, and you put actually a script attribute in your HTML page saying nonce and equals that random value, and you have the same nonce in your header. And if they match, browser would let it work. And if it doesn't match, browser just blocks it. What I wanted to say with this slide is that there is default source directive, and if you don't explicitly specify a resource type directive, the value for the directive will be derived from default source. So, which means if you don't have, for example, font source declared in your policy, the value for font source will be derived from default source. And yeah, the same thing for any source type directive. Now we learned that if you have multiple source expressions in one single directive, you have to match any of them. There must be a match with any of the expressions to let the resource load, to be loaded. So now what if you have, say, your network infrastructure is in such a way that you, for example, have edge devices that add some some default content security policy, and then other web servers, actual application web servers, are actually defining content security policy that's specific to this particular web page. So technically, yeah, you can have multiple content security policies, but there's a caveat that in this case, you actually have to match every single content security policy that you have in your that you declare to allow the web page to load the resource. Basically, in this case, what would it be? Like the only matching URL that would satisfy all three policies would be something like HTTPS API.example.com, and only in case if self is also coming from example.com. Basically, you'll see later how this works. Or you can combine actually multiple content security policy headers as a single header with comma-separated values. It's not CSP thing, it's like HTTP thing, that you can combine any HTTP header, any multiple HTTP headers into single HTTP header with comma-separated values. It's also applicable to CSP. And basically, these are two equivalent. But, yeah, unfortunately, you don't see much here, but the point of this slide is you cannot basically, if you try to combine policies by just concatenating them, it's going to be like different policies, because in first case, you have to match every single source expression, and in case of second policy, like it becomes normal policy and you have to match only like any of the source expressions. So these are different policies, they have different semantics. Yeah, speaking about semantics, as I said, like if there is no explicit declaration of a resource type directive, its value will be derived from default source. So now if we have, for example, a content security policy that declares every single possible source type. So we have script source, style source, image, font, child, connect, object. That means that default source doesn't have any meaning in this case. So ABC is like not used by any of them because like every single policy is overriding the value. So basically that means that you can, since all of these sub-resource directives are saying that I'm allowing, that only domain origin D is allowed. So basically you can express the same thing as by just saying default source D, and they have the same semantics, but the grammar is like completely different, right? So yeah, if you skip none, that means that basically empty list of source expressions is the same as none. And the same thing is with default. Here is how spec interprets if you do not specify the scheme. So basically, these three directives are semantically equivalent. Because example.com, if the third one, scheme is missing, and spec is like in very long sentence with like, I don't know, 1, 2, 3, 4, with 4 negations, it defines what you should do if scheme is missing. But basically what is it saying? That default scheme, if it is missing, it's HTTP. And like this is an example of how spec is not really like easy to interpret. And yeah, if you have a port, if you have the scheme and missing port, then default port will be assumed to be there. Like for HTTP, it's going to be 80, HTTPS 443, and WebSockets 80, 443. Spec also defines Gopher, but like who's using Gopher these days? For most permissive policy, like most of the content security policy 101 blog posts or like tutorials are saying that most permissive policy is like default source star, which means that any source, any resource type can be loaded from anywhere. But it's actually not true, because even default source star is still not allowing inline scripts, or it doesn't allow data URLs or file system URLs or blob. So basically most permissive policy is actually this one, the lower one. It's default source star, unsafe inline, unsafe eval. And it's exactly the same as like not having a policy. On the other hand, most restrictive policy is going to be default source none. So missing none means like empty expression, source expression list means none. Default source none, but since frame ancestors and like form action and sandbox are not derived from the default source, you have to explicitly specify them. Because by default, if you don't specify, say, form action, it is star, meaning form can be submitted anywhere. Or frame ancestors is also star by default. If you don't explicitly specify it in the policy, any website can load your web page. Can load your web page in a frame. Host source. I don't remember what is this. Oh, okay. So there's one exception. The connect source is basically not about loading resources, but about connecting, making connections from your website. And connect source is responsible to control where your website can connect to. So basically self and HTTPS served by example.com. It's the same rule, like any of the source expressions should match. So example.com, for example, doesn't match anything. Scheme doesn't match. It doesn't match self because self is actually HTTPS example.com. It's like origin. And we're trying to connect to HTTP, so connection will not be allowed. HTTPS example.com port 8080 will also not be allowed because it assumes that if you don't specify the port, then port has to be 443 for HTTPS schemes. On the other hand, this one would work because it matches the origin. It's the same as self, so it is allowed by self. This one is also allowed because 443, like it's the same as not specifying 443 because default port for HTTPS is 443 according to content security policy spec. WebSocket wouldn't work because we don't allow WebSocket by any of the source expressions. The same is with this guy. Some CSP examples from real world. This is actually like CSP, a little simplified CSP that's served by CNN. It's pretty bad because they are not only allowing anything from anywhere, they are for some reason duplicating the same data because basically in script source they're saying we allow scripts to be loaded from everywhere and from self, which is already nonsensical. But on top of that, they allow unsafe eval and unsafe inline. And plus they allow data URI for images. So basically it's better not to have any policy than to have something like this. Another example is, it's actually some Russian website. This is the content security policy it serves. It's pretty long and I'm sure it can be like optimized. Another like maybe worst policy ever, it's served by arm.com, actually. They set allow directive name, which is deprecated, and allow actually never made into official CSP spec, and it was just experimental feature for implemented by Firefox. And they use frame ancestors, and frame ancestors directive was introduced by CSP level 2. And for example, Safari doesn't know what frame ancestors is. And Safari doesn't know what allow is because allow never made into the spec. So this policy served by arm.com is actually like doing nothing at all. Some error handling by browsers. And this is a pretty big issue. Like for example, if you have any HTTP header cannot contain non-ASCII characters, pretty much, like if we generalize. And CSP is not an exception. Like you cannot have non-ASCII characters in CSP. And if you put something outside of ASCII range, actually browsers behave pretty differently. Chrome will ignore the entire policy, entire directive, and Firefox will ignore the particular token that has a problem and will still parse the rest of the tokens. For example, if you have script source self and foo, in case of Chrome, everything will be ignored and like scripts from everywhere are allowed to be loaded. And in case of Firefox, self will still be enforced. It's actually a bug because spec is clear on this and spec says that just ignore the problematic token. And keep the rest, keep other source expressions. And Firefox still didn't fix it. Another bugs that we reported, I don't know, 15 bugs on Chrome. These two are actually security bugs. They are fixed, but they still haven't removed the security flag from the bug, so you cannot see it. It's not available to everybody. But for example, I think it's pretty big. Spec is saying that if you have a policy like this, like star dot something dot something, you actually have to match match URLs that are ending with dot something dot something. But Chrome was actually allowing something dot something. So basically, Chrome was allowing x.y/file to be loaded, although according to the spec, it shouldn't be loaded. And it's pretty. I think it can be a big source of problems because people read spec, people implement their policies according to the spec, but then turns out that that browser is not interpreting the spec the same way as you are. Or this one, script source star, according to the spec, shouldn't allow any data or file system or blob URIs. But Chrome was actually allowing it, and you can have something like this in your on your web page. Like your cross-site scripting payload can be data URI, and it will perfectly work in Chrome. And you would have false sense of security by thinking that Chrome implemented it properly. There is a cool feature in CSP called CSP reporting. So what happens when you specify a policy and your browser violates the policy? So basically it tries to load a script from somewhere that you are not whitelisting. Actually, browser would send a report to you. To specify where a report should go, you put report URI directive in your policy, and you can specify multiple or like one URI where the report will be sent. And the rule is the spec is saying that report should go to every URL you listed there. Actually, some browsers, well, all browsers except Firefox will actually append the cookie if report URI shares if report URI has the same origin as the web page where policy is enforced. And although spec is defining the format of the report, every browser implements its own format of the report. Like, for example, you can see that it's exactly the same violation generated by Firefox and Chrome, and like even by the size of the report, you can see that they are different. So if you are dealing with CSP reporting, just normalize them before processing. Oops. Oh, sorry. Report has limited types of data that browser can share with the endpoint that collects the reports. So if you want to add some extra data, there is no way to extend the report format, CSP report format. So the only way is to pass the data as like query string parameters of your CSP report actually. And by the end of the presentation, there's a link on a blog post on how Twitter, for example, is handling reports, and they are putting session ID in the CSP report URI. So basically, they can tell that this report was generated by this browser legitimately, because otherwise, like if you have a vulnerability in your web page, all browsers in the world will start sending you CSP reports, and you cannot really distinguish if this report is legitimate or somebody is just bombing you with the same post HTTP messages that contain something that looks like CSP report, and like it can be pretty big source of, for example, denial of service attacks. There is another good feature that you can deploy your policy in report-only mode. So basically, report-only header acts exactly the same way as content security policy header, but it evaluates your policy, it evaluates the violations, but it doesn't enforce the violations. It just generates the report. It will generate the report in the same way, but it doesn't break the page. If you have a problem on the web page with CSP and you mistakenly are blocking some resource that is not supposed to be blocked, content security policy report only will help. So basically, the good practice is to roll out your content security policy as report only for a week, and like tweak it and fix it until you stop receiving reports that are not supposed to be there, and you only receive actual attack reports. And then, like a week later, you switch to actual content security policy header. Yeah, I should have mentioned this in the beginning of the presentation, but why we started looking at CSP. So, company where I work, we make a network appliance which modifies the HTTP responses. We can inject our own script into the web page, or we might modify the actual scripts that are already there. And if web server is using CSP, we need to actually adjust the CSP before forwarding that HTTP response to the browser. And it's not actually that easy task. It's not like just concatenating, or like, I don't know, if, for example, if we are introducing new origin, and like if our appliance is adding, say, jQuery.com, it's not like you are appending just jQuery.com into the script source. It has its own rules, and we decided to implement a library which optimizes things, like has full-blown parser with error locations, positions, and warning positions, and it can answer questions like the same questions as browser would ask, browser CSP implementation would answer, sorry. It's used in production, so it's pretty well tested. So yeah, what are the problems that our library is trying to solve? For example, when you have to merge two policies, basically there was a policy served by the web server, and now we want to merge that policy with something that we want to add. That would be union merging, and it's not like just this example shows that it's not just basic concatenation. You have to properly merge the values. We can merge we can merge using intersection strategy also, and this would basically mimic what the browser would do if you have multiple policies. Basically, you have two policies. Now you have to come up with some third policy that would satisfy both policies, basically. So if you had A and the policy that's saying default source A and B, and another policy which says default source none, so none would win, because the only URL that would match both policies would be, like, there is no such URL. So, for example, default source would become none. For script source, the first policy is saying default source AB. There is no script source, which means script source will derive from default source, which means for the first policy, a script source is also AB. And for the second one, it's star. So the intersection of them is going to be AB. And like for everything else, there is no intersection, so you just get rid of it. But it's hard to manually write, and like better to use something like our library, for example. We also have this website, cspvalidator.org, which uses some features of the library on the back end, and like you can test and you can either enter URLs to query actual content security policies of some websites, or like click that button and we'll populate a URL of a website that actually contains CSP to analyze later. Or you can like come up with your own policies and like test them on the website and like merge using union strategy or intersection strategy. See the warnings, see nonsensical warnings. We will also optimize the policy for you, and you can compare if there was actually optimization that took place, or it was the same and you have actual like optimal policy. I just said this. Actually, our website is also serving a content security policy, and I think that, like, this is an example of good policy where first you write your website So you don't have to have inline scripts or any kind of inline resources because it's good practice, it's good for caching. So you move any scripts that you have to external files. And yeah, for example, this policy covers everything. Like we cover all types of resources. We collect our reports. We allow only resources that we actually need to load. And we are trying to be like as strict as possible. Like you start with default source none, and then you whitelist your resources one by one. So yeah, we reported like, I don't know, more than 10 bugs against browsers. We start helping with actual CSP spec by submitting pull requests, which are being accepted sometimes. And yeah, these are like good resources where you can learn about CSP, and that's pretty much it. That's it. And I'll be happy to answer any questions. I understand this is not like covering, but like, yeah, any CSP related questions would be great. So the rule is, spec is saying that you have to the URL should match any of the source expressions. So if it matches either, what did you say? Star? Huh? So it's kind of nonsensical because star always wins. Because like any URL would match star, so there is no reason to specify anything other than star. Kinda.
CSP size. Is there any limits of the CSP size?
Spec doesn't talk about it, but browsers actually, well, Chrome has a limit on HTTP header. So yeah, that would be your limit. But spec doesn't define any limits.
Okay, thank you.
Okay, I have a question. We've implemented CSP some time ago, and we got rid of report URI because we tried to avoid using report URI by malware guys. Something like we can't fully trust the JSON parser we wrote for URI parser, for error parser, and we would like to ask if there are any report URI scripts ready that are quite good enough, that are checked for vulnerabilities and that we can use.
Sure. So there are two things. First, for example, there was a bug in Firefox that existed from August last year till October this year. It was generating CSP reports for valid, completely valid web pages that contain nonce attribute. And so, yeah, people were being like hammered by CSP reports generated by Firefox. So lots of people just disabled CSP reporting, at least if user agent is Firefox. To answer your question, there are third-party guys that are collecting your reports for you, and basically they take the risk of being hacked. It's CSP, it's getsentry.com. It's paid service, but they normalize the report for you, and like they provide you the normalized version of everything. Yeah, they parse the JSON, they take care of everything. It's paid. There's another guy which is free. The website is cspreporter.io, I think, or cspreport.io.
Yeah, we use that guy, reporturi.io.
Oh, reporturi.io, yeah.
But he turned us off because too many errors.
Too much traffic?
While testing in report-only mode. But I wonder if you just insert some script and it runs as an error, and some analyst got this error in his console, for example, and you run something like script alert, something like that, any XSS, if the report analyzer is written
So
badly.
for that, actually spec is saying that CSP report MIME type, content type should be application CSP report. but only Chrome implements it. All other browsers just still put application.json.
Yeah.
So when all browsers start doing it properly, and you can tell already from content type, and
Okay, thank you.
yeah. Yeah, unfortunately, it's not solved now. And like the only thing is to outsource it to some guys that are ready to take the vulnerability risk. Cool, thank you.